All right. Hello, my name is Elliot Norlander, and this is my individual game, what's it called? Game walkthrough or development screencast for the TDDE23 game programming course. I have, along with a person called Hugo Nilsson, developed a brawler slash top-down wave defender game called Keeper of the Crypt. And the basic idea for this game is that you fend off waves of different enemies that gets progressively harder throughout the game. And the objective is basically to kill these enemies as efficiently as possible and without dying. It actually gets pretty difficult at the end. So that's the core idea for this game. So let's hop on over to Godot, which this game has been developed in. All right, so here we are in Godot, and what we can see here in front of us is the first level of this game. We have so far developed two, but this is the first one. And I should also mention that my thought for this screencast is just to go through like a couple of things that I find interesting and that I personally worked on quite a bit. So anyway, here we are at the first level. As you can see, we have designed it in 3D. This is a 3D game. We can move around in the level here. And as you can see, we have, this is the player. If we hop out of the focus view here, there we go. So basically, each of the two levels look very similar construction-wise. So we call this player levels because, well, it contains the player as well, not just the environment. So we have taken a modular approach throughout this game to try to be able to reuse as many of the components as possible for each level and each stage. And this was, I think, a good approach in general. It did make some things more difficult when you think about the fact that we only made two levels, but let's say we were to create like 20 levels, then this would have been really efficient. And we did a lot of the groundwork for that, which I'm quite proud of as well. So anyway, each of the levels have kind of a similar approach. We have the environment, which is the level itself. And we got the player, and we got a spawner that spawns out the enemies. And the spawner is custom for each level, because you want to place the different spawn points like at different locations for each level. So that's why we made it this way. We also have a game manager that controls like the flow of the game, the pause menu, the heads-up display, which is in the top of left corner here. You can't see it really, but it's like just a simple counter. And we also have the spawning node or the spawning scene for the XP orbs that drop when an enemy is defeated. All right, so what we're going to take a look at now is the spawning mechanism for this game. And right now, as you can see, I'm in the spawner scene, and it might look quite empty because it is. It really is just a Node 3D and a audio player that plays like this sound when you progress through levels. However, when you take a closer look, you can see that there is actually quite a bit to it, as you can see. So basically, we have set up a modular system to be able to handle the enemy spawns. So what we did was we took a good look and we said, okay, how do we want the waves to be structured? And then we said, we want it to be structured into segments of 5 levels. So basically, 5 waves, sorry. So you have 5 waves, and then you have a very short intermission of like 5 to 10 seconds just to regen, and then 5 more waves, etc., etc., etc. So what we set up was kind of like as you have in Java, where you have an interface, we set up a modular structure that looks like this to easily be able to make like a large amount of scenes in a short period of time. So we just have two lists. We have an array of enemies, which are like, for this wave, what type of enemies do we want to be able to spawn in? We also have a counts array, which is just how many of each do we want to be able to spawn in. And we also have like a manual delay that we could remove if we just wanted to default to another value. This makes it really easy to, for instance, in player level 8, if you go here, exit here, and then we click the spawner node, then we can see here in the inspector of Godot, let me just do this. So what we have here now is an array of wave configs. So what we can do then, which is really good, is that if we do this and type babe, we can create these repetitive scenes, like pre-made scenes or pre-made like tree resources that we can reuse really quickly. So let's say I just wanted to add another wave to this. Let's say I want to repeat the first wave of the first segment, the last thing we do. Then we could just do this and drag it in. So it's really efficient to just create this type of resources where we just set, like as I said before, we set these three fields, and then we can just repeatedly create these resources really quickly, which is really, really nice in my opinion. So how does the spawning actually work then? Well, as I said before, we use the wave config structure to repeatedly do like copies of the same scene, kind of. And basically the way we actually spawn in the enemies is by looping through this long array of the config files. And then for each of those, we go through the different aspects, both the enemy type and the count, and then we spawn them in. Then basically, spawner keeps track of the killing of the enemies as well, which then sends a signal up to the game controller, which I'll talk about a bit more in a second here, that each wave has been cleared. So basically what we have created is a kind of a master and slave structure, with the game manager being the master and the spawner being the slave. So the game manager basically keeps track of the overall flow of the game, and the spawner keeps track of the the enemy related spawning itself. So if we take a closer look at the game manager, which is kind of like, well, it is the master in the master-slave relationship. And basically what we do in the game manager is we start by connecting to the wave cleared signal that emits from the spawner node. And then we like immediately start the first wave, like when starting the game, obviously. And then we hand off the work to the spawner node, and we just sit and listen in the game manager for this wave cleared signal. And the wave cleared signal basically tells us, okay, now we have a cleared wave, obviously, so we need to increase the wave counter and trigger the spawner or the spawning manager to spawn in the next wave. And this basically loops on and on and on until we hit the level limiter, which then spawns in the second level here. So if we are to take a closer look at some of the enemy types, we have three enemies in this game. We have the barbarian, we have the rogue, and we have the knight. And all of these enemies function pretty pretty like similarly, I would say. We have a pre-imported like GLB mesh file, which is the like character itself. We tried actually to create our own characters in Blender, but we realized that that was way too much work for this course, and it was simply way out of our league because none of us had previously worked with Blender, so that was quite a wrong step, or a step in the wrong direction rather. Anyway, so we use character body 3Ds as our root node to signify that this is actually a character, but this is the like, how should you say, the actual asset, which has all of these like child nodes that you could, for instance, look at. So let's say you wanted to check for damage made to a specific part of the body, like the head or something like that. Then we could target the specific areas, but we have not done damage that deep in this game. But basically, the way the characters work or the enemies work is that they have the pre-rendered like mesh. They have a hurt box, which is the how could you say, the area, the hitbox that the player can strike, and they have like a attack area, which is the area that can strike the player. So that's the core components of each enemy type. Well, they also have a small audio player that plays sounds when they're hit, and so forth and so forth. And if you were to look at the script aspects of the enemies, you would actually see that they function quite similarly, I would say, in the aspect that we have, for instance, these exported variables, so it's easy to go and tweak the like walking speed, the attack offset, etc., easily during the development, as well as the like roaming aspect of the enemies. So basically, the way they work is when they spawn in, they are automatically set to in a wandering state, where they just like pick a random direction, walk, pick a random direction, walk. So they're basically patrolling the level. And then once the player is actually inside the detection range, as you can see here, it locks onto the player and chases it. And all of the three enemies do this to some degree, but the like individual settings for them are different. So for instance, for the rogue enemy type, which is this one, that has a crossbow, you want the enemy to, like, how should you say, stop further away from the player, aim, charge, and shoot. As for the like barbarian, which is this one, which is the most basic enemy, you would want it to go all the way up to the player and slash or attack. And for the knight, you would also have a like a decision-making function, because it has both a quick like stab or jab attack and a charged spin attack. So basically, we have a decision function there as well to create some type of like character depth. And it would be really easy to create new enemies in the future. That should be said as well. Since we have, if you remember the wave config structure, it's very easy to just pull in new enemy types into the enemies array and then spawn them in. So that's really good with the modular system that we have created. And yeah, that basically concludes the this game development screencast. As I said, I did not have time to walk through everything. There's simply too much, I would say. Overall, this has been a great experience. It was both me and Hugo's first proper game engine game, which was really fun, and we have learned quite a bit, I would say. So yeah, thank you for listening, and goodbye.